Hello everyone, and welcome back to the Fluctus Channel. Aircraft carriers demand an extraordinary level of maintenance to remain fully operational and combat-ready. These floating air bases are among the most complex machines ever built, and keeping them in peak condition requires a structured and continuous maintenance strategy. This process is divided into two primary categories. Routine maintenance, conducted daily, weekly, or monthly, focuses on identifying and resolving minor issues before they escalate into larger problems. In contrast, depot-level maintenance is carried out at specialized shipyards where the carrier undergoes a comprehensive overhaul. This includes detailed inspections, structural assessments, replacement of worn components, system repairs, and the integration of modern technologies to ensure the vessel remains effective in evolving combat environments. Dry dock maintenance is one of the most critical phases in this life cycle. These massive dry docks are specifically engineered to accommodate the enormous size and weight of aircraft carriers, providing a controlled environment for extensive repairs, modifications, and upgrades. Before entering the dock, the aircraft carrier must undergo a carefully planned preparation process. This includes defueling sensitive systems, removing aircraft and equipment, thoroughly cleaning and coordinating with tugboats to precisely maneuver the vessel into position. Every movement is calculated to ensure safety and accuracy during docking. Once inside the dry dock, the scale of the maintenance operation becomes apparent. The carrier is subjected to an intensive, multi-layered overhaul process. This includes detailed hull inspections to detect structural weaknesses, application of anti-corrosion measures to protect against the harsh marine environment, servicing and refurbishment of propulsion systems, upgrades to electronic and communication systems, and improvements to crew facilities. Each of these tasks is critical to maintaining the carrier's operational capability. A key focus during this stage is the overhaul of propellers, particularly on Nimitz-class carriers. These massive components are essential for propulsion and must operate with extreme precision. The process begins with complete disassembly, followed by thorough cleaning and inspection. Any worn or damaged parts are either repaired or replaced. High-pressure water jet cleaning is used to remove debris, marine growth, and contaminants from the blades and hub, restoring smooth surfaces and reducing hydrodynamic drag. After cleaning, the propellers undergo precise calibration and balancing procedures. This ensures they rotate efficiently, minimizing vibration and noise while maximizing propulsion performance. Proper balancing is essential not only for efficiency but also for reducing long-term wear on the propulsion system. Another essential aspect of carrier maintenance is painting. While it may appear cosmetic, painting plays a vital role in protecting the ship's structure. Specialized coatings shield the vessel from corrosion, saltwater erosion, and environmental damage. Before painting begins, sensitive areas such as electrical components and control systems are carefully masked to prevent contamination. A primer base coat is applied first to create a strong foundation, followed by multiple layers of protective top coat. These layers not only define the ship's appearance, but also significantly extend its operational lifespan. The handling and repurposing of anchors between carriers is another complex operation, requiring precision and expertise. Each anchor must be carefully prepared with anti-corrosion coatings, including primer layers, protective top coats, and anti-fouling treatments to resist marine growth. Specialized systems are used to capture overspray and prevent environmental contamination during the process. When installing the anchor, powerful winches and lifting equipment are used to carefully position it. The anchor is aligned with the hawse pipe and securely attached to the chain and hull using heavy-duty shackles and pins. Maintaining anchor chains is equally critical. These chains endure extreme stress and constant exposure to harsh conditions, making regular cleaning essential. High-pressure water jets are commonly used to remove debris and buildup, while chemical treatments may be applied to dissolve barnacles and marine growth. Once cleaned, the chain is deployed through the hawse pipe, ensuring smooth and reliable operation when the anchor is lowered. Rope heaving is another fundamental maritime technique used during docking and transfer operations. It involves throwing a lightweight rope with a weighted end toward a target, such as another vessel or a dock. Precision is essential to ensure the rope reaches its destination accurately. Once secured, the rope is used to pull heavier lines into place, enabling secure connections. This seeming like a pull technique plays a critical role in large-scale docking operations. The arrival of a carrier at the dock signals the beginning of one of the most complex engineering processes in naval operations. The refueling complex overhaul. During this phase, the USS John C. Stennis is carefully secured to prevent any movement. Aircraft are removed from the flight deck, allowing access to deeper sections of the ship. In some cases, portions of the flight deck must be removed piece by piece. This involves cutting, lifting, and transporting massive panels to designated work areas, providing access to internal systems. Removing the rudder is another major step in the overhaul process. Weighing approximately 48 tons, this massive component is detached using hydraulic cutting tools and precise maneuvering techniques. The process requires strict control to ensure the rudder remains intact and undamaged. As part of the upgrade, a new 123-foot mast is installed, significantly enhancing the ship's communication and aviation capabilities. To accommodate these upgrades, large structural sections must be removed. A 50-ton aft section, including bulkhead and deck components, is carefully lifted using specialized cranes. This process demands careful planning to maintain the integrity of the remaining structure. Similarly, the sponson unit, which supports various systems including weapon mounts, undergoes replacement. The mounting area is prepared and decontaminated before the new unit is installed with precise alignment. Heavy lifting operations continue with the installation of upper-level structures. A 1/6-ton upper section is secured, lifted, and positioned using advanced lifting systems. Once in place, it is anchored using high-strength fasteners to ensure stability. Following this, an 81.9-ton radar tower is installed, significantly enhancing the ship's detection and communication capabilities. Propeller removal during this phase requires innovative engineering solutions. Specialized rigging fixtures are developed to transfer the weight of the propellers from the ship's structure to lifting cranes. This reduces stress on the vessel and eliminates the need for temporary supports, improving both safety and efficiency. Finally, the rudder is reinstalled and aligned with the hull. The 27-foot rudder stock, weighing approximately 20 tons, is carefully lowered into place, extending deep into the ship's structure to provide a stable foundation for steering operations. Ultimately, the refueling complex overhaul represents one of the most demanding processes in naval engineering. Conducted approximately every 25 years, it ensures that aircraft carriers remain operational, technologically advanced, and ready for future missions. Beyond repairs, this process modernizes critical systems, extends service life, and enhances combat capabilities, ensuring these massive warships continue to dominate the seas for decades to come. At the heart of modern naval power lies another process few ever witness: the transformation of a massive U.S. aircraft carrier from a static structure into a floating warship. This moment begins inside the dry dock, where years of construction meet one defining milestone: flooding and launch. At Newport News Shipbuilding in Virginia, the only facility in the United States capable of building nuclear-powered aircraft carriers, the future of naval aviation takes shape. This shipyard has produced every U.S. Navy nuclear carrier, including the latest generation, the Ford class. Leading this class is the USS Gerald R. Ford CVN-78, a vessel that represents a major leap forward in technology, automation, and combat capability. Unlike previous generations, Ford-class carriers are built for efficiency and higher operational tempo. Advanced systems such as electromagnetic catapults, modern radar, and improved weapons handling allow these ships to launch more aircraft faster and with greater precision. This evolution continues with new carriers under construction, including the USS John F. Kennedy, CVN-79, and the USS Enterprise, CVN-80, both steadily progressing toward operational readiness. As construction nears completion, one of the most critical systems is tested, the Electromagnetic Aircraft Launch System, or EMALS. Unlike traditional steam catapults, EMALS uses electromagnetic force to launch aircraft from the flight deck. During testing, heavy-wheeled platforms simulating aircraft are repeatedly launched to verify system performance under real operational stress. These tests ensure that every launch is controlled, reliable, and capable of supporting modern aircraft demands. But beyond technology, one of the most dramatic moments in a carrier's life is its first contact with water. The dry dock flooding that precedes the launching process is carefully controlled and executed over several days. Millions of gallons of water are gradually pumped into the dock, raising the water level around the massive hull. Slowly, the carrier begins to lift from the blocks that have supported it since its earliest construction phase. This is the moment the ship transitions from structure to vessel. For the first time, it floats. Once fully buoyant, the carrier is guided by tugboats, carefully maneuvered out of the dock, and moved to its outfitting pier. This stage marks the beginning of final system integration, testing, and preparation for active service. It represents years of engineering, coordination, and craftsmanship coming together in a single moment. From steel assembly to advanced systems integration, every phase leads to this transition into open water. That's the end of this video. I hope you enjoyed it. Make sure to subscribe to this channel so you don't miss any of our new content. See you next time.